Hey there, class. Welcome back. This is a different way of doing the notes, but I thought I'd just scroll through a little bit of what we did on the islands and the age of the Hawaiian Islands this week. And remember, we start off talking about the big island of Hawaii, the latest in a long series of islands. And if you look at this picture right here on the board, the kind that was sectioned off right here, that is supposed to be kind of a bigger version of this part down here that I just circled in red. And the Hawaiian Island chain that goes off this way here, um, basically is a small piece of this long chain of islands that goes all the way up and then finally disappears in the Aleutian Trench. And so I'm asking you to draw that, check out where it is. And when you're looking at Hawaii, especially this part right here that I'm coloring in right now in red, that's the latest in a long series of islands where you've got the land right here, brand new. By the time you get to the other side of the big island of Hawaii, you're looking at land that is about 250,000 years old. By the time you get up here to Maui, you're looking at about 1.3, 1.4 million years old. Molokai here, about 2 million years old. Oahu, 3 million. Kauai, 5.1 million. And you notice a pattern here. So I was asking students to notice this pattern. Most everybody picked up on it right away. The age was in the blue. And as you move across, the islands get older and older because when you're looking at the direction that the Pacific plate is moving, the Pacific plate is carrying along the islands with them. And when they move off of the hot spot, the volcano right here, the largest volcano in the world, as a matter of fact, the largest mountain in the world if you measure it from the base, as you move off that, it is slowly wearing away. You can see the same type of rock right here in California. If you look at the Sierra that I'm outlining right here, the Sierra crest has basalt on it, volcanic rock. Underneath it, and I'll circle this right here where the trees are, is granite. This was taken recently in the High Sierra, so this is California right here. And I'm mentioning that because we can see this right here in our own backyard. If you look at, for example, that piece of basaltic rock right there, that piece of volcanic rock that you see up here, this was taken up near Truckee, California, just a few months ago. And Truckee is just down the hill over here. This is from the ski resort called Boreal. You can see volcanic rock up here, and then these fields of granite. And the important part is this is all this red that I'm coloring in here is igneous rock. Here in the Bay Area, we've got our own giant piece of igneous rock right here in our backyard. This is Montara Mountain. Montara Mountain is a large piece of the Sierra Nevada that is broken off and it's traveled all the way up here along the San Andreas Fault. And if you go back in time about 25 million years ago, we've used that MYA quite a bit in this class. 25 million years ago, this chunk of mountain right here was down in what is now Los Angeles. What's interesting, this particular picture was taken at San Pedro Valley Park. This area that I'm coloring in here, should probably use a different color, is sedimentary rock. So you're looking at a big piece of igneous rock, Montara Mountain, that's run into the sedimentary rock where we live. I have another picture coming up, here of a local beach here in Pacifica, and you can see the wonderfully displayed layers of sedimentary rock. You see the stripes in the hillside there. This is worn away, and you can see the sand that's been compacted over the years. Here's a better picture coming up. You can see, for example, this one right here. The keys, my car keys, are down here for scale, and you can see depicted here wonderful layers of the Old Devil Slide Trail. Sedimentary rock, these have been laid down roughly between 30 to 50 million years ago. So after the dinosaurs died out, but well before people were on the scene. And again, you're looking at the sedimentary rock. So remember, we've talked a lot about the rock cycle, how the rocks change form from type to type, how it's critical to life on Earth. And that was where we started when we were talking about our study of Hawaii. If you look at Hawaii, all of these islands mostly are giant pieces of igneous rock. Now, certainly you can find some sedimentary layers because of the weathering that's happened, but you're looking at islands that start off basically as big pieces of volcanic rock. We had made a little mention of this atoll right here, Midway. Not quite an island anymore. It's really, really old, 27 million years old. If you check out the atoll of Midway, it's really just, let's see if I can change my colors here to, I'll stay with red for a little bit. It's a tiny, tiny little island. And I'm going to draw a circle of the island, and it's got an airstrip on it. So to give you a sense of the size, it's basically just big enough to land some airplanes. It was the site of a huge battle, not the exact island, but the Battle of Midway was a huge deal in World War II, all because you could land airplanes there. I also mentioned it because you might remember Dr. Guccione was talking about all the plastic in the ocean. Midway has and has been for millions of years a very important place for birds to nest, but the problem has been washing up on the shores are piles and piles of plastic, and literally every week they fly out of Midway boxes of plastic trying to keep it clean for the nesting birds there. So that was why Midway Island got a special little mention in the class. Some of these atolls that you see along here, let me pull the pen up tool up again. Some of these atolls that you see around here don't even really quite break the surface of the ocean. They're just down to coral reefs. They once were islands as big as Hawaii, but now they've been worn down and they're just little tiny, tiny, tiny pieces of islands until they completely disappear kind of north of Japan and west of Alaska. I want you to think about as we go forward this week. That's why this picture was in here right there. How did animals like birds and the plants get to Hawaii in the first place? When you're in Hawaii, you're looking at one of the most isolated island groups in the entire world. So backing one more time up to this picture right here, which is all drawn up now, but this is also posted on the website. This group of islands is by far the most isolated island group in the world. So how did life get there? I want you to think about that for this week. How did all the living things that you see get there? And also the invasive species, things that moved into Hawaii after after humans arrived, started doing a number on all the native species that were there. So we really want to think about that. Finally, when we were starting off with the geology, the one last little picture I wanted to show you, you might recognize this. This is the Pacific up here, right here. I'll put a little line across it so you can see it. Our school is just about there. And when you see this hillside right here, where Oceana High School sits, I'll kind of circle roughly where Oceana High School is, right about there. Right here, going off this way, you're looking at the San Andreas Fault. It doesn't really go up in the air like that. That was in one of my better pictures, but it continues on. It goes all the way around the Pacific. As a matter of fact, let's use that little mistake right there and turn it into an arrow. If you put an arrow and you put a little dot just about where the McDonald's is, just a little bit past it. So there's Golden Arches McDonald's there in Pacifica and Manor. That was where the 1906 earthquake began. That's where the San Andreas Fault started to break, and it broke going north all the way up until you get to Marin County. Our school sits on the Pacific Plate, and relative to this plate over here, which is, let's write it up here, the North American Plate, relative to that plate, we are moving in this direction, while this one is moving in this direction. When you saw Montara Mountain a little earlier, that picture of Montara Mountain, go back a couple pieces right here. Montara Mountain, that 25 million year number, that was about the time that it was in what is now Southern California. But if we now go back to this picture, in about, another 25 million years or so, what is now Los Angeles, Dodger Stadium will be sitting right about here in Pacifica. The plates are always on the move. We happen to share a plate with the island chain of Hawaii, and if you notice the way the chain is moving, we are going that same direction pretty much as well. That's where I'm going to leave it today. Have yourself a wonderful week 34, and I hope you like the little recap here with the iPad. Take care. Bye-bye.